Hey everyone, this is FixReef, and today we have this AI Hydra 26 HD, I believe, in for repair. I already started taking it apart. It came in with a problem of a failed connector, so hopefully it's going to be an easy repair. But let's take a look, because in most cases there is nothing easy about repairing these lights. The problem is usually with removing this connector board. It's very, very delicate. It's got many pin headers, and if you're not careful, you can rip them out. So hopefully we're not going to be doing that today. I already started removing the board, so I'm going to be super careful here taking it off. And what we now have is essentially the main board and the two LED clusters. Let's take a look at the connector that's broken. You can see that the power connector is completely destroyed. And the concern that I have is this the only problem? So for now, let's just focus on testing this connector. So I'm expecting positive to be here, negative to be over actually on this side, and there should be no continuity between positive and negative leads. And there is a dead short between them. That's a concern, because if there is a dead short on this, is it on the connector or is it elsewhere on the board? And more importantly, is the main controller damaged? But when there is a dead short like this on the main power input, it usually indicates the problem is right at the power input and not anywhere else on this board. So let's take a look. So the next thing I would do is I would actually remove the connector, and once I remove the connector, I would test again whether or not I have a short. Now, this board is actually attached to this huge aluminum heatsink. So doing any kind of soldering on this board right now is really an exercise in futility, because it's not going to, you will never ever reach the temperatures necessary to remove any of these components, because all of your heat is going to be dissipated into the heatsink. So I'll have to remove the main board. The main board is glued to the heatsink, but it's not as bad of a glue as some, so it actually does come off with just a little bit of effort. Just like that, and the board should be off. Nice and clean. Now we can actually work on this board. The board seems quite clean. Let's see if we can replace this or remove this connector with just a soldering gun without using low melt solder, which may or may not be possible. Adding a little bit of flux. And my plan is to lift up one side first and then to lift up the other side. I do not actually care about the condition of the plug or the connector, because it's already destroyed. I just want to make sure that I don't destroy the main board. Yeah, this comes off fairly easily because it's already significantly damaged. Yeah, the whole mechanism of this connector is pretty much gone. Wow, it's completely destroyed. Well, that makes it easier to remove then. And now the other side. and it looks like the connector is gone. Look, it basically disintegrated the moment it came off the board. Okay, now before I do anything else, let's clean up all of the pads. Once we have them all nice and clean, then we can actually do some testing. And just a little bit of cleanup. Look, looks brand new. But the big question is, do we have a short? What is this exactly? That's probably me scratching the pad off a little bit. Hopefully. Okay, no, I don't think. I think it's just a scratch. All right, let's do the testing. All right, looking at it, this is not supposed to be happening. So this is supposed to be shorted together, and these two are supposed to be shorted together. And in reality, we have this pin over here somehow connected to this. What I believe is over on this end is that this is positive over on the left. This is supposed to be negative over on the right, and this negative and positive are shorted somehow, somewhere. So I think it's time to look under the microscope, look at the traces, and find out where everything is leading. So this is indeed the positive, and you can see how this is going to this capacitor over here, the positive end of the capacitor, and this is the negative, and it's supposed to be over here. Down the negative, you can see that this whole pad over here is all ground. This is ground, and this is not even conducting anything. So this is the reason why this pad was not showing continuity, is because you can see that this is not connected to the ground at all. But this is connected to the ground, and the ground is currently shorted to positive, and that's not a good thing. So what can possibly short? We know that ground is fairly common across all of this, right? So ground is going to go. So ground is going to be conducting anywhere. The positive end of this, however, is not going to be as common. So let's find out where our short is. The beginning of the circuit is this. This is where it's supposed to convert from 36 volts down to whatever 5 or 3.3 volts. So it's good to make sure that none of this is actually none of these components are shorting. So we'll start there. Okay, there's a short across the capacitor, but that's expected because that's a direct short anyway. It's possible that the capacitor is bad, but it's also possible that something else is causing issues. Because then there is this capacitor. I have an idea. Why don't we do some voltage injection and find out if anything is heating up. Okay, for voltage injection, I'm going to just do the simplest thing. I'm going to add some solder to these pads, not a whole lot, because I'll need to clean this up eventually. And I'm just going to attach a couple of wires. So let's just make this a red wire, since this is supposed to be positive. And looks like I have this brown wire over here that is going to be negative, just like this. And I'm going to give it something very, very low. I'm going to give it just a couple of volts. And now, armed with some rubbing alcohol, let's find out if anything heats up. you know, this capacitor over here is heating up right away. Let's look under the microscope and see what this looks like. Okay, so in this area, I'm looking at this capacitor. I'm going to see if I can make sure that you have a good view of this whole area. So there it is, all soaked in alcohol. Let's turn it on, and right away. Okay, so this capacitor might be our issue. So let's remove the capacitor and see if that solves the problem. All right, the capacitor is out. And let's see if the short is still in place. Okay, let's test for continuity. Let's see if I run it against the original leads. There is not that short anymore. And if I run continuity test against the capacitor, it's completely shorted. Okay, so we found our short. I have a donor board with an identical capacitor here. So what we're going to do is we're going to take it off, take the measurements, and find the replacement. All right, so here, let's take the measurements off of the donor board. Looks like it's 5.8 microfarad. Since the input is about 36 volts, I would imagine that the voltage characteristics on this one is going to be about 50 to 60 volts, would be my guess. So 4.7 up to 6.2 microfarad is what I would expect of this capacitor. So I'll remove the donor. All right, now let's prepare our board for the new components. First off, I'm going to replace the capacitor. Need to clean up the both pads real well. Now a good scrub. Look, it looks like new, practically. Now we need some fresh leaded solder. And we're ready to install the new component. I'm probably just going to use my soldering iron to install it. It's not going to be all that demanding. And that should do. It already has leaded solder on it, so we just need to add a little bit more because we're going to have a fairly large connector installed here. That should be good enough. Now I'll need to find a new connector. Let's try this one. Let's see if this one fits. To me, this looks like an exact fit. It goes straight on. Looks like that's exactly what we need here. Okay, let's put it in. because this is a brand new connector. We'll need a little bit of flux. And the other side. And let's make sure that it's all bonded really well. I am not going to use the hot air here because this will destroy things. Too much plastic around this area. Okay, I think we got it. This looks really good. Okay, so a little bit more cleanup. Primarily just to get the flux out. I just like the board to look really nice and clean after I'm done with it. That looks really good. Okay, check this out. We got the connector completely replaced, and the offending capacitor that was shorted also completely replaced. Now let's reinstall and see if it actually works. Now, reinstalling rather the board is kind of tricky because you have to make sure that it aligns in such a way that when the connector board goes on top, this middle header is going to align with the main board as well. So, but other than that, the adhesive is still very strong, so it's not going anywhere. And align it. It aligned really well with my main board here. Everything is good. And very, very carefully start pressing it in. There's so many connectors going in, it's very easy to mess it up. Okay, looks like everything is in. What I should have done is I should have also tested the LEDs while it was all open, and might as well tested the headers to make sure that they're not damaged. But the board is already in place, so let's just bite the bullet, plug it in. Now, I only added a little bit of current to my lab power supply, so I don't want, if there is more damage, I don't want it smoking. So if the light may shut off immediately once I turn it on because it does not get enough juice. All right, plugged in, let's turn it on. Okay, we have a pulsing light, that's a good sign. This means, I believe, that this light needs to be provisioned. Okay, so I just configured the light, it came on, it's probably running right now at full brightness. Of course, the problem is that you probably see here that the green channel is not working. The green LED over here and the green LED over here are both off. I just tested them and they're both actually working just fine. The problem is that somehow they're not being turned on. So the green channel is causing issues. So we're going to take it apart again and fix what's left. Okay, the green channel. The green channel is connected to the top two pins on the right. So technically speaking, if we were to say connected like this, we can see that the green LED is working, connected like this, and the green LED is working. So the problem is not with the LED clusters. The problem is either with the main board or with the connector board. It's totally possible that when somebody else tried to open this up, um, some pins got, some pads got damaged. So let's take a closer look at what we have. Okay, first let's focus on this two. This seems to be working and looking good. And then this two. That's also connected. So likely not the connector board. How about this? All right, so how about this? And this looks also connected, and I'm not seeing anything lifted. So I think both of these are good. Now let's take a look at this on this side. This seems to be good. This one you can't easily see, but this also, they look like they're off a little bit, but that's just the artifacts of this, the original reflow. All right, so I think that the connector board is just fine. I might have spoken too soon about the connector board. The problem is that I only checked these two connectors over here, and these connectors are fairly solid. But of course, the LEDs are connected out of the board and onto the main board, and the main board connectors are here. Well, three. There is one here, and one here. So we can trace how the green channel is actually connected to the main board. So there is two pins. These two traces go through the V's on the other side. We can now flip it over. We can find these two traces going here. One of them actually connects to the other header, to the other LED cluster. And then the other one needs to go onto the board. And there is one to the, this one goes to the board, and this one goes to the board. So there is a header on this side that connects it all. Now, this is our header, and let me get under the microscope to show you the problem with this header. So this is the header in question. Look at this. This pin over here is moving easily, so this is not connected to the board at all. And this is exactly where one of the green channel traces come into. Others, let's see if any others are bad. Now this one is also moving quite a bit. Oh, you can't see it, can you? Let me see if I can get it this way. See how it's shifting with my pick. So at least two pins are not fully connected to the board. And by the way, in general, this is usually my problem with AI Hydras. You can see that they're really not very well soldered onto the main board. A slight bit of movement and they come off. It's almost like they're not soldered but glued to the board, and that's not how you're supposed to do things. So what I'm going to do is I'm going to reflow all 6 pins on here with just my iron and make sure that everything is connected perfectly. I apologize if you can't see all of this because of the angle of my microscope. I'll try to move it in such a way you can see it, but see now each pin is actually covered in solder, and solder goes all the way around it. And do the same on the other side. And just in case, I'm going to check all of the other headers. Also good. Okay, just a little bit of cleanup around the connector that I've reflowed. This looks really nice and clean. So this should give you an idea that it's never a simple problem. It's never something that is as simple as a power connector. You've got, just on this light, we have an issue with headers. We have a capacitor that went short, and we have a problem with um, the actual connector, power connector. Okay, carefully press everything in. Let's plug it in again. See if we get the green channel. All right, I just configured the light, and now we have all channels working, including the green channel. So this light is now fixed. All right, so again, let's recap. For this light, we came in with a broken connector. I had spare connectors, brand new for this one. Removed the connector, found out the problem with a short on the capacitor, a power capacitor. Replaced the capacitor, the light is working, but the green channel is not working. The green channel is not working because one of the pins, or a couple of pins actually, on the header got disconnected, likely because you know, when you guys try to pull the connector board off and you're not super careful, it takes minutes to take it off, not seconds, but minutes to take it off. And if you're going too fast, you damage the headers, and those headers are never soldered properly. They're never soldered to the point where they're going to be strong on that board, and they just come off. We are lucky here that none of the traces got pulled off the connector board, and it was just a matter of reflowing those pins back on the pads. But that completes this repair. Thanks for watching. If you enjoyed this video, please like and subscribe, and I will see you next time.